Hello everyone, welcome to an academy. In this lesson we will cover about the concept of friction force, and to understand what friction is we first have to consider what a contact force is. The contact force is a force that arises between two bodies when they are in contact. As an example, most forces of involving push and pull action are contact forces. So a man pushing a cart or you pulling a string is actually a contact force. In reality, or in a microscopic level, subatomic level, a contact force is actually an electromagnetic force between the charged particles at the surface of contact. Remember that phrase. It is actually an electromagnetic force. This is a very important conceptual question that can be asked in the examination. Now, contact forces generally acts between two fluids, or two solids, or a fluid and a solid. Okay, now we will move on to two parts or two components that make up the contact force. The first is the normal force. The perpendicular component, okay, a perpendicular component or the normal component of the contact force to the surfaces in contact is called the normal force. Now, if this is the first component that we have of the contact force. The second component is the friction. Frictional force is the parallel component of the contact force to the surfaces in contact. So for when two surfaces are in contact, there arises a contact force. Now that contact force has two components. One is the parallel component, another is the perpendicular component, as we see in the next diagram. If this is the body, one body in contact with another surface, so the lower part of this body is a surface which is in contact with this ground surface, which is shown by this line. Now the contact force which arises here has two components. One is the parallel component with the surface. So parallelly with the surface acts a force F, which is the frictional force, and another is the perpendicular, the normal component to the surface, that is the 90 degrees. This is the normal component, so this is the normal force, and Fc is the contact force in the particle. Okay, so I hope this diagram helps you to understand the component breakdown better. Now I need to cover let me give you three examples of frictional forces that arises in our macroscopic world. The first is viscous force that occur in fluids, air resistance due to in gravity and in air in the atmosphere, and buoyancy on a solid that acts between a fluid and a solid. Okay, we will study about buoyancy in Archimedes principle as well, and in fluid mechanics. So now let us first know about the different types of friction that arises. Two main important types of friction arises. One is the static friction, another is the dynamic or kinetic friction. Now another friction also arises which is called the rolling friction, which is basically a type of dynamic friction. So the first friction we will study is the static friction. It arises when two surfaces in contact do not slip on each other. So the word static means unchanged or at rest. So slipping, the word slipping here indicates that there is no relative motion between the surfaces in contact. So this friction arises when the surfaces in contact do not slip on each other. Remember that. There are some important features of this type of friction, static friction. It is self-adjustable. By self-adjustable I mean that the more you increase for example, the more you increase the applied force on a body in contact with another surface, the friction increases by an equal amount in magnitude as well as in the opposite direction to maintain the static equilibrium or the relative rest condition between the two surfaces. For example, when you are pushing a cupboard on a ground with a force F, it does not slide or it cannot move because the force of friction of a same magnitude F opposes it to move. This force of friction is the static friction. So as long as you keep increasing the force of application on the cupboard, the static friction also increases in an equal amount of magnitude to oppose your applied force. Okay, but there is a downside to this characteristic. it is that there is a maximum limit to which the static frictional force can rise up to. It doesn't keep on increasing as long as you keep on increasing the applied force. It has a limit. This limit is called the limiting fraction. Beyond this limit, the condition of slipping or the condition of relative motion occurs. Okay. Now, the limiting fraction experimentally is proportional, found to be proportional to the normal contact force, that is the N, as we have read earlier. So, according to the laws of mathematics, we have that the limiting fraction or the maximum frictional force is proportional to N. So we have a proportionality constant which is mu s given here. Now mu s is called the coefficient of static friction, remember that. Now, since static friction is not a constant quantity, it's a variable quantity, by which I mean that as long as you keep increasing the applied force, the static frictional force also increases by an equal amount. So we can say that the static frictional force is less than equal to the normal contact force. Okay. Now, another characteristic of static frictional force is that it opposes the motion relative to the other body in contact if friction is absent. So and another example is friction does not always oppose motion. We may think that friction arises to oppose the motion of the application force, but that is not always true. Now let us understand these 2 points. The first point especially, that it opposes its motion relative to the other body in contact, with an example. Now let me give you 2 bodies here. One is A, B, one is A. Now B is on a surface and there is an application of a force on the right hand side on the body B. Due to the application of the force F on the right hand side, the body B moves on the right. Now frictional forces, because of the application of the force F, static frictional force arises on the body B because of this surface that is in the opposite direction. This friction opposes the motion of the body B. Now, for the body A, which is on top of B, there is no friction. There is no sliding motion because I mean, by that I mean that since the body B is being pulled by F, so the blocks move together, right? Since they move together with an acceleration, because it is being moved by a force, there is no sliding motion between A and B, because A is not because A is at ground. Sorry, A is at rest relative to the body B. Okay. Now, the frictional force between A and B is on the right hand side because with respect to B, the force of movement is on the right hand side, that is FB. Because of FB, there arises a frictional force on the left hand side, which is opposite the motion of FA. Now, this is the first point that we discussed, that it opposes its motion relative to the other body in contact if friction is absent. Friction is absent for the upper body, that is A. Now, for the second point, we explain by this fact that which force is responsible to accelerate the block A? The answer is Fa. Fa is responsible for accelerating the block A because A is on B at rest, which is moving with an acceleration F by the mass of the total system. Now, without friction, the motion of a vehicle cannot be stopped. Remember that. The transfer of motion of a body to another is possible only due to friction. This is exampled by these 2 bodies. Now, this is what static friction entails. Now, next on we move to dynamic friction or kinetic friction. Now, dynamic friction occur when surfaces in contact slip or there is relative motion between them. That is, they cross beyond the limiting fraction, that is the limit of the static fraction. The direction of this friction on a surface is opposite to the velocity of that surface relative to its contact. Remember this phrase, okay? Now, The dynamic frictional force is directly proportional to the normal force N acting between the two bodies. So Fd is the dynamic frictional force equal to mu dN, where mu d is the coefficient of dynamic friction. We should also remember that it is independent of the relative velocity of the bodies sliding, provided that they are not too large. If the relative velocity of the sliding bodies are not too large, the frictional force is independent of that velocity. Otherwise, it is opposite the direction of the relative velocity. Okay. Now note these two important facts, that uh, the static frictional force is lies between 0 to mu n. Mu n is the limiting fraction, the maximum limit. The direction and the magnitude of static friction adjust so that no slipping occurs, since the basic condition for maintaining static friction is no slipping should occur. So the direction and the magnitude of the frictional force adjust itself to maintain that balance. The frictional forces do not depend on the area or the shape of contact, keeping n constant. If we keep the normal force constant, then the area or the shape of the shape of the surfaces in contact do not matter regarding the value of experimental observation of the frictional forces. And there's another important fact that you have to remember, is that the coefficient of dynamic friction is less than or equal to the coefficient of static friction. Okay. We should also know about rolling friction. Now, rolling friction occurs when an object, preferably a rigid body like a sphere or a cylinder rolling over a horizontal plane without slipping, faces friction in reality because of deformation at the point of contact. Now, deformation at the point of contact is a point that will be explained later in the next video. So rolling friction occurs during this condition when a rigid body is rolling over a horizontal plane, like an inclined plane, without slipping. Okay, basically it's a type of part of static friction. The measurement is done by the ratio of the horizontal force needed for uniform velocity on a horizontal surface to the normal force is the coefficient of rolling friction. So you have F equals to mu r n. N is the normal force and F is the horizontal force needed for uniform velocity. This horizontal force is equal and opposite to the force of friction. So this is basically F. Now note this statement, that mu r is less than mu d is less than mu s. So mu's coefficient of static friction is the maximum and coefficient of rolling friction is the minimum. Okay. So students, I hope that you have understood what friction is. In the next lesson, we will cover about a few more pointers regarding the measurement of friction and what basically entails about friction in a more conceptual microscopic level, and how does friction help us, and what are the ways in which friction can be minimized. Hope to see you the next time.